China just made a massive leap in robotics, and the entire world is watching closely. At the 2024 Spring Festival Gala, 16 humanoid robots took the stage and performed a perfectly synchronized dance alongside human performers. These weren't just pre-programmed machines executing rigid movements. These robots adapted, balanced, and interacted like real dancers. Meanwhile, Figure AI has just severed ties with OpenAI to develop its own in-house artificial intelligence, signaling a major shift in the AI industry. Tesla's Optimus robot now faces serious competition in the field of humanoid robotics, and Nvidia is working on training robots to move like professional athletes. The race for the most advanced AI-powered humanoid is intensifying, and the stakes have never been higher. At the heart of this robotics revolution is China's latest showcase. The Spring Festival Gala, an event watched by over 1 billion people, became the stage for a breakthrough moment in AI and robotics. The humanoid robots, built by the Chinese robotics company Unitree, flawlessly executed a traditional Yangi dance. They moved in perfect sync with their human counterparts, tossing and catching handkerchiefs, spinning with precision, and maintaining complete stability throughout the performance. What makes this remarkable is the fact that most humanoid robots struggle with basic balance. A small shove can send them toppling over, and even walking smoothly can be a challenge. Yet, these Unitree H1 robots showcased an entirely new level of control and fluidity. They achieved this through 3 months of intense AI training and a positioning system called Laser Slam, which allowed them to detect subtle variations in the stage floor and adjust accordingly. Each Unitree H1 robot stands at 1.8 meters, 5 feet 11 inches, and weighs 47 kilograms, 104 pounds. These robots first made their debut in August 2023 and even appeared at Nvidia's GTC conference in 2024. The price tag? Roughly 650,000 yuan, about $90,000 per unit. Beyond the impressive dance performance, this event signifies something much bigger. China's growing dominance in AI and robotics. The country is making rapid advancements, and this is just one example. Another is DeepSeek, a powerful AI assistant developed in China that recently made headlines for its capabilities. However, its rise has also sparked concerns about data security, particularly in India, where officials are closely monitoring its activities. Even Elon Musk chimed in with his opinion on DeepSeek, though his reaction was far from enthusiastic. While China is grabbing attention, other players in the robotics industry are making strategic moves. Take Figure AI, for example. This company has been developing a humanoid robot called Figure 2, designed for both commercial and residential use. Last year, Figure AI raised an astonishing $675 million in funding, bringing its total valuation to $2.6 billion. So far, the company has secured $1.5 billion in funding to bring its vision to life. The big shock came when Figure AI announced that it was cutting ties with OpenAI. Originally, OpenAI was a key investor, and the two companies planned to develop next-generation AI models for humanoid robots together. But now, Figure AI's CEO, Brett Adcock, has revealed a surprising shift. The company no longer wants to rely on OpenAI. Instead, it will build its own AI models entirely in-house. Why? According to Adcock, outsourcing AI development isn't enough. Running a humanoid robot in real time requires AI that's fully optimized for complex, real-world tasks. Adcock believes that only by controlling both the hardware and software can they create a truly capable humanoid robot. Interestingly, OpenAI isn't backing down from humanoid robotics either. They're investing in a Norwegian startup called 1X, which is also developing humanoid robots. On top of that, OpenAI recently filed a trademark for AI-powered humanoids designed to learn, communicate, and even entertain. So while Figure AI is going solo, OpenAI is still deeply involved in robotics. For Figure AI, the first major step will be in industrial applications. BMW has already begun testing Figure humanoid robots in their South Carolina factory. If the trials go well, it could pave the way for large-scale industrial deployment. Adcock has also hinted that Figure AI will unveil something groundbreaking in the next 30 days, heightening anticipation in the robotics industry. Meanwhile, Tesla is pushing forward with Optimus. Elon Musk recently took to X, formerly Twitter, to highlight Optimus's robotic hand, claiming it was more complex than a Fabergé egg. This immediately sparked competition. Clone Robotics, another robotics company, responded by claiming their own humanoid hand was not only lighter, but also stronger, thanks to artificial muscles rather than traditional metal motors. They even joked that their robotic hands were soft enough to give massages and hugs. This debate over robotic hands is part of a larger competition. Tesla's motor-based actuators versus Clone Robotics' muscle-based approach. Tesla's method emphasizes precise motor control, while Clone Robotics argues that artificial muscles provide more strength, fewer parts, and less weight. The question is, which approach will prove to be more effective in real-world applications? But the most ambitious robotics project yet might be Nvidia's latest work. Teaming up with Carnegie Mellon University, Nvidia is developing a revolutionary training framework called ASAP, short for Aligning Simulation and Real-World Physics for Learning Agile Humanoid Whole-Body Skills. The goal? To make humanoid robots move like professional athletes. To train these robots, researchers used motion data from some of the greatest athletes in the world. They studied Cristiano Ronaldo's powerful strikes, LeBron James's iconic silencer celebration, and Kobe Bryant's legendary fadeaway shot. They even analyzed dance moves performed by K-pop star Rose. Using a tool called TRAM, they converted these videos into 3D motion data, which was then used to train the robots in a simulation. However, making robots move like humans isn't as simple as copying video footage. There's a massive challenge known as the real-to-sim-to-real gap. Robots might move flawlessly in a computer simulation, but when they're tested in the real world, factors like motor heat, mechanical stress, and unexpected physics can cause them to fail. To overcome this, Nvidia's research team developed a unique method. The robots first train in a simulated environment. Then, when tested in the real world, they collect data from every movement, even the failed ones. That data is then fed back into the simulation, refining the AI and making future movements smoother and more natural. This means that the next time a robot attempts a basketball jump shot or a dance spin, it performs with greater accuracy and fluidity. But pushing robots to their physical limits comes at a cost. Complex movements can wear down hardware quickly, motors overheat, and mechanical stress can cause components to break. During Nvidia's testing, 2 humanoid robots suffered damage due to the intense movements they were performing. To solve this, researchers are now working on damage-aware policies, AI-based adjustments that help robots adapt on the fly before critical failures occur. The financial cost of humanoid robotics is also significant. Unitree's H1 humanoid robot is priced at around $90,000. Figure AI is investing billions in its long-term vision. Tesla is pouring massive resources into Optimus. Some companies are focusing on commercial and industrial applications first, targeting factories and warehouses, where businesses are willing to pay for cutting-edge automation. Others, like 1X, are aiming to develop humanoid robots for everyday home use, which presents a completely different set of challenges, such as dealing with unpredictable environments, children, and pets. One thing is certain: the AI and robotics race is accelerating at an unprecedented pace. China is making bold moves with humanoid robots that are improving faster than ever. Figure AI's decision to break away from OpenAI signals a shift in how humanoid AI will be developed. The battle between motor-based and muscle-powered robotic hands is heating up, and Nvidia's groundbreaking work could change how robots learn and move forever. The big question now is, what comes next? Will Figure AI's secret project redefine humanoid robotics? Will Tesla's Optimus finally achieve Musk's ambitious vision? And will Nvidia's training methods unlock the secret to truly lifelike robot movement? If you enjoyed this deep dive into AI and robotics, make sure to subscribe. We'll keep you updated on all the latest breakthroughs in this rapidly evolving industry. Stay tuned.